Hello everyone. Today let's solve the problem number 140 word break 2, right? So what the question states here, we are given a string s and a dictionary word see here we are given a string s and word dictionary, right? So we must split s into valid words from the dictionary, right? So what we must do, we must split s, this one, we must split s into the valid words from the dictionary, right? So then, and we have to return all the possible sentences, right? So each word can be reused multiple times. So each word here can be used multiple times. Just keep this in mind, right? So if no splits is possible, we have to return an empty list. So if no splits, see here for the example, in the example 3, no splits is possible. In that case, we have to return the empty array, right? So we have to return an empty list basically. This is fine. Now in the S we have cats and dog. Word dictionary we have cat. This one, what do we call cats and sand as well as the dog. So output that we need to return here is cats and dog, cats and dog, right? So this is fine. uh, Here in this case we have pineapple, pen, apple, right? So word dictionary we have been given apple pen, pine, pineapple, right? So we can just go with pine, apple, pen, apple. So this is one, and pineapple, pen, apple, again same. Pineapple is complete one thing, and pen then apple, pine, this one, yeah, lemon and apple. So this is fine. Now we have to note that we are allowed to reuse the dictionary word any number of times, right? So they have strictly mentioned in the question. So there is no this thing, a restriction on that, right? So here we cannot split, so we have given this one. What do we call? We have written the empty list or the empty array. So this is fine. Now let's do one thing. Let me consider the first example for the approach. So you can just go with the same this thing. You can apply the same thing for the example 2 or example 3. I insist you to go with the example 3, as we get only the empty list on the this one, empty array on the this one for the example 3 or the input 3. So I insist you to go in the same way for the example 2. So let's consider example 1 for the approach. First thing, before considering the approach, let me tell you one thing. So we will be going with a backtrack. So what will be going with, we will be going with backtrack, right? So just keep this in mind again. So we will be going with a backtrack, right? So this is fine. uh Again, I wanted to tell you one thing. So we'll be going with a backtrack method, right? So this is it, nothing. So now let's move on with the approach part. So we have cats and dog. Also word dictionary we have cat, cats and sand, dog, right? So first what we'll do, so let's go with a step-by-step explanation. I'll just go with a step-by-step explanation, that is using backtracking, right? So we'll start from the index 0. Always we'll start from the index 0 for the backtrack most of the times, right? So we'll start from the index 0. We'll try every prefix of s, every prefix of s, right? So again I'm telling, we'll start from the index 0 and we'll try every prefix of s, right? So first we will be considering cat. So prefix of s is cat, right? So here we'll be considering cat, right? So this is fine. So cat in the dictionary, what we will do, cat is in the dictionary. So first we will try prefix of s, and so we will check whether cat is present in the dictionary. See here. So cat, this one, cat is present in the dictionary, right? So we will, what we'll do, we will recurse on sand dog basically. So we will recurse on this one. I can just write it here, sand dog, right? So this is fine. Now the next part is, we'll be going with the cats, right? So we will be going with the cats. So this is fine. So here we will check whether cats is present in the dictionary or not. So cats is present in the dictionary. What we'll do, we will recurse on and dog, right? So I'll just go with and here, this one, dog. This is fine, and dog, right? So this is for the index 0. Basically we are starting from the index 0 and we are trying every prefix on s, right? So we are done with the first part, right? So first step. So next step, uh, let's go from the, sorry, let's go from the sand dog basically, right? We are going from the sand dog. So here we will check whether sand is present in the dictionary or not. Yeah, sand is present in the dictionary, right? So we will check whether sand is present in the dictionary or not. Sand is present in the dictionary. So what we will do, we will recurse on dog. We will recurse on dog, right? So this is simple. I hope this is clear, man. Next, within this itself, we will check whether we have went with sand. We will check whether dog is present in the dictionary. Dog is present in the dictionary, right? So let me write here dog. Then what we will do? So we will consider the sentence cat, sand, dog, right? Cat, sand, dog, right? So we have already recursed on dog by considering the sand. Now we are considering dog, and dog is present in the dictionary. So we'll go with the sentence cat, this one sentence, whole sentence within the string cat, sand, this one dog. So this is also fine, I hope, I believe. Right. So next, let's go with the final one here, the third step. Right. So now we will consider and dog. So I'll just go with and dog. Right. So this is fine. And dog. So now what we will do? So we will check for and. Right. So we will check for and. So now we will check whether and is in the dictionary. So you can clearly see here and is in the dictionary as well, right? So we have checked and is present in the dictionary. So what we'll do, so we are going with and dog, right? So we will recurse on dog. So we will recurse on dog, right? So we are going with the backtracking. So obviously we'll be making use of the recursion. So every step we have done the same thing when we considered cats and dog. So first, initially we started with the index 0. So we went with the cat. So we are recursing on the sand dog, right? So again we considered cats. Cats was present in the dictionary. We are recursing on the and dog. So same goes with two. Here we have come to the third part. So we are considering and dog. So we have considered and is in the dictionary, and we are recursing on the dog, right? So next we will be considering dog, quite obviously, right? So next we'll be considering dog, quite obviously. And here we will check whether the dog is present in the dictionary, right? So if you see here, dog is, again, let me tick this one, dog is present in the dictionary, right? So we will go with the sentence, we have went with cat, sand, dog, right? So now this time we will go with cats and dog, right? So this time we'll go with cats and dog, right? So this is fine, simple, right? So we are done with the main three steps. Now we will collect all the valid sentences, right? So we can collect all the valid sentences, and uh, we can just return in this way, right? So we can just return cats, uh, and so we have to return the valid sentence itself, right? So we can go with cats and dog, one thing. And the second one here would be this one, cat, sand, dog, right? So I'll just go with cat, sand, dog. So this is fine. Yeah. So we are done with the coding part. Right, so sorry, we are done with the approach part. So we have got the two valid sentences here, cats and dog, and another one is cat, sand, dog, right? So this is fine. We are done with the approach part. So I hope the solution part is completely clear, man. I hope the approach part is completely clear, man. Very simple. We have discussed this one step by step, right? Every step I have explained. This one is the fourth one, final, this one valid sentence. So this one will be returning this one as output, right? So the output that we got here is cats and dog, cat, sand, dog, right? So which is equivalent to the output that they have mentioned for the example one within the question. This one, cats and dog, cats and dog, right? So this is fine. So I hope this part is completely clear, man. Let me remove this one entirely, right? So now we are completely familiar with the approach. Let's do one thing. Let's quickly discuss the complexities part, man. So what would be the time complexity here? So we are going with the backtracking, we know that. So in the worst case, it can go up to 2 to the power of n, right? So the overall time complexity would lead to 2 to the power of n. Why? Because we are exploring every substring, right? So and we are this one, pruning the memoization, nothing but, so this is much faster in practice, right? So whole time complexity would be this one, overall time complexity would lead to big of 2 to the power of n, right? So what will be the space complexity here? The space complexity would lead to big of n into k, right? So the space complexity would lead to big of n into k, right? So where n is nothing but the length of the string and k is nothing but the average sentence length, right? So this is due to the recursion and storing result part. We know recursion part is n and k is nothing but the average sentence, nothing but we have to store the result, right? Finally, so if you remember, we have to store this one, cat and dog, cat sand dog. So k is nothing but the storing result part. So this one is result, and this big of n is for the this one recursion depth, right? So I'll just write here rec recursion, right? So this is nothing but r result. This is fine. Yep. So this is the overall space complexity basically. So the time complexity and the space complexity for the code that we'll be writing in the future would be big of 2 to the power of n and big of n into k. I hope the complexities part is completely clear, man. As we are completely familiar with the approach and the complexities part, we are good to write the code. Let's start writing the code. Right. So first thing is we have to store the dictionary in the hash set for the big of one lookup. So I'll just go with set here. So this one, let me go with string. So let me go with set variable set here. Let's create instance of the hash set. I'll just go with hash set. So let me pass the word dictionary here. So word dict have been given, right? So let me pass this one. This is fine. Next step is we have to go with the memoization accordingly with the approach, right? So we have to map from the index, nothing but list of sentences, right? So I'll just go with map. So let me go with integer here. So this one has to be list. This is also fine. Let me pass the string. I'll just go with memo. So this one will be new hash map. This is also fine, man. This is fine. Yep. Now let's start backtracking from index 0. We have to backtrack from index 0. We know this one, right? So before backtracking from index 0, we have to perform the backtrack, right? So let me make use of the helper method backtrack for this. So let me give here private. So this one is list, which is of type string. So let this is capital S. Capital S itself, right? So I'll just go with the backtrack here. So I need the parameters s. So I need start as well to start. So this is fine. I need set, uh, which consists of basically which is of type string. So this is fine. And I need map. So basically this will be of type integer. What am I doing, man? This is fine. Finally, I need list, which is of type string. Right, so this is it I need, I guess. So this one I didn't write at all. So where did this go? Huh. So map we are going with, right? So we need two key and a value pair. So basically one is this thing, integer. So this is fine. Integer comma, this L has to be capital, not I basically. So list of, again this one T has to be small here. Let me close this one. Basically this will be considering memo parameter. Right, so this is fine, man. Sorry. Now first step here, if the result for this index is already computed, then we have to return that one, right? So I'll just go with if memo dot contains key of, let me pass the start here, means if the result for this index is already computed, then we have to just return it, right? So here on this case I'll just go with return memo dot get, let me pass start here. So this is fine. Now let's do one thing. Let me go with the list just to store the sentences starting from the current index. So I'll just go with the list here. Let me go with the string. So result equals new array list. So this is fine. So the next step would be, let's go with the base case. If we have reached the end, we have to add the empty string, nothing but this is used basically to build the final sentence, right? So let me write the simple if condition for this. So I can just write it on this way. If start equals length of the s, then I'll do one thing. I'll just go with result dot add. So this is fine. Now let me return result. This is also fine. Let me come out of this one entirely. Let's do one thing. Let's try every substring that is starting at start, right? So let me go with the iteration part here. For so this one will be end equals start plus 1. So end less than or equal to s dot length. This is fine. And finally, let me go with plus plus. This is also fine, man. So within the for loop, let me go with string, nothing but word variable. So I'll just go with s dot substring. So from start comma end. So this is fine. So now if the word is in the dictionary, then we have to recurse, right? So accordingly with the approach, when we that's what we discussed, right? So if the word is in the dictionary, so then we have to backtrack for the remaining string, nothing but recurse itself. We have to backtrack for the remaining string, and then after doing that, we have to combine the current word with all the results from the recursion. So basically these things we have to do. Let's start now. So if word is already in the dictionary, uh, or if not already in the dictionary, if word is present in the dictionary, sorry. So this one has to be if set dot contains, let me pass word here, this is fine. So we have to backtrack for the remaining string, so I can just write it on this way. So this has to be list string. This is fine. Let me go with sub list. So this one is fine. Let me pass the backtrack. So let me copy this one. Let me paste it over here. So this one will be s comma end comma set comma memo. This is fine. Now let's combine the current word with all the results from recursion, right? So this is the only step that is left, right? So I'll just go with string. I'll just consider sub of this one basically from the sub list. So within the for loop, so I'll just write the simple if condition. So I'll just go with is empty operation. This is fine. I'll just go with result dot add of word. This is also fine. The final step is I'll be going with the else here. Else, let me go with the result dot add word. So this one, let me concatenate this one. Let me leave space. So this one will be plus sub. This is fine, man. So we are done with the coding part. So almost we are done almost. So we are left with one thing, that is we need to save the result and memo. So did I miss anything, man? No. So yeah, let's save the result in the memo. So let's check. So I'll just give here memo dot put. So we have to consider start and result. This is fine. So finally we have to return result, right? So did I miss anything? One second. I think this is fine. Yeah, let me format the code once. Now we are done with the backtrack helper method, right? So we have to start from the this one index 0. I mean we have to backtrack starting from the index 0 basically, right? So let me return here. So let me paste the backtrack helper method. So we have to go with the parameters s. From the index 0 we have to backtrack. This is fine. Set also we need memo, right? So this is fine. So we are done with the coding part 1. So let me format the code again and let me hit the run button. I hope this works for sample test cases. We have the error here. What error? Line number 8. Semicolon expected. Where semicolon? Why semicolon is expected when I'm going with a private this thing, right? Private list of string. This is fine. Backtrack I have given. What error I am getting here? Line number 8, 17. First, let's clear this line number, this thing. Backtrack. We have the parameter s. This is fine. Int start is there. This is fine. Set of string. This is also fine. Uh, oh, I have not mentioned the set here, man. This one, this part. This is also fine. Map of integer. This is fine. Comma list string memo. This is fine, man. Let me hit the run button. Uh, Yep, this error is gone. And the line number 17, we have one more error. So semicolon expected. Yeah, this one has to be semicolon. I have given colon, this one, comma instead. So now it has to work. Let's see. Again, cannot find the symbol S. So what I have given here instead of S, line number 12, and also I have made use of S, right? Didn't I have given S? What's the problem here? So where I am using here, this one within the this one backtrack method. So this one list string result equals this is fine. Oh, I have missed the parenthesis here. Damn, bro. So this is fine. Now let me run this one. Yeah, now this is getting accepted. Means the sample test cases are getting passed, right? So parenthesis was the problem. So let me hit the submit button. I hope this works for all the test cases, man. Let's see. So here you can clearly see all the test cases are getting passed. Means the code works absolutely correct in this case, right? So uh, I hope um, I hope the solution part is completely clear along with the approach and the complexities. For now, this is it. Thanks for watching, guys.